Good morning, everybody.
Good morning.
We're approaching 8:30 start time, and we still have some people joining us, so. Good morning, good morning, good morning. We even have some that I don't recognize, so that's okay. All are welcome to learn some geometry. Okay, so it's 8:30, so I like to start on time, and if people miss out on it, then all they have to do is watch the video later. The other videos from yesterday are posted now on YouTube on my channel. So we have, I have 2 days worth of pre-algebra and I have 2 days worth of geometry. So the other two lessons are up there if you need to go back, which is good. This time, that's one of the good things is that for review, if we do end up having to do this longer than 2 weeks, I am gonna have to give an assessment at some point, and then those will be good review. You'll get to see that video as much as you want. Fast forward past stuff you don't need, go back, pause it, things like that. So that is one useful thing. Yeah, I don't know why it's having me have to admit everybody, but hopefully that'll be okay. Okay, everybody start doing this problem. I want the surface area of this composite solid. So it's made of a half cylinder. And the other half of that cylinder, imagine that we cut it right in half and split it, and we put them along the sides of a rectangular prism. Now you have the depth of it is 3 meters. That's across the object or into the object. 6 meters across. Now 6 meters is it's just the dimension of the rectangle. It's not following along this curve here. So the 6 starts and stops at these vertices here. Hope everybody can see that. Now the height of this prism, it's not a prism, but this height of this object is 4 meters. Okay, and if you see the base is this almost elliptical in shape, but not really. But that's the base, and there's the other identical one on the bottom. So you really have 2 of those, and then you have, think of them as stacked up on each other, 4 meters high. Okay, so you guys can talk amongst each other for ideas if you're having trouble seeing it. Make sure, David, you turn your, oh, you already got it. You're showing because you have it, but it's hard to see. I can't see yours. Let me, oh, you have an answer. You're showing your answer. Okay. All right. Thank you for doing that. You can always post your answer in the chat because I think only I can see your chats. Okay. I just admitted 3 more people. I think I'm going to turn off that feature tomorrow where I have to admit people and that there's a waiting room. I think it's much better if you just directly come in. Okay, so you're working on this problem. You're getting the surface area. So what you're going to want to try to do is maybe separate it. Get the surface area of the cylinder. Get the surface area of the rectangular prism separately and add them together with one catch. So there's something else that has to be considered. Make sure if you don't want to see other videos, you guys pin my video. You right-click mine and then pin it. Anybody else who's got their video up, I'm going to stop your video, okay? Or you can close up your video. And again, you're welcome to turn your mics on for questions. Everybody else automatically came in muted. So you'd have to unmute yourself to be able to ask a question. Okay, so I'm going to start off on the surface area of that cylinder. So it's going to be 2 base areas plus the lateral area. And the base area of the cylinder is pi r squared, right? And another pi r squared. So there's 2 bases. That's what this is here. The lateral area is going to be this unfolded rectangle where the base of it is the circumference and then the height of it, right? And then the circumference is 2 pi r or d pi, right? And so you need to get this area by multiplying this information times the height, okay? So what is the diameter? Well, it's the 3. The 3 goes across the whole thing. So the diameter is 3. So 3 pi is the circumference. The height is the height. It's 4. And I'm going to keep things in terms of pi. All right, so I have this 4 times 3 pi is 12 pi. This is my lateral area. The base is pi r squared. So if you look at the radius, if the diameter is 3, the radius is 1.5. So radius squared is 2.25, and don't forget the pi. Okay, and that's the area of one base. See, there's all these things you have to alert your brain to come up with and not forget. You could walk out the door with only one circle on this because you're going through the problem and not checking it throughout, okay? Gotta admit more people. Okay, so here at this point, that's only one area, so you need to double that, and you're gonna get 4.5 pi is the two bases. It's a long problem. And you know what? On the test, this is what it looks like on the test. It's one of these. So don't just say, well, this one's too difficult. I'll wait for ones that I can do. No, you got to do this one. So this is, add these together. 16.5 pi gives you just the cylinder. What about the rectangular prism? I saved the easier one for later. Well, how do we do that?
3 times 6 times 2 plus 4 times 6 times 2.
What was our shorter formula though?
Oh yeah.
So let's break it down. So let's see. So for that I have okay, so I want the two bases plus the lateral area.
Lateral area equals perimeter of the base times height.
Well, let's look at the base though. Let's just look at examine the base. Okay, the base down here and the other base up here are the two bases. And this is 6 and by 3. You can see that's a 3. 6 by 3. So it's 18 down here and 18 up there. So that's 36 for the two bases. Okay, now the lateral area, the problem, here's the catch that I warned you about. The problem with the lateral area is that not all of the lateral area is on the surface of the entire object. The left side of the box and the right side and the left side are covered up by the cylinder. That right side is covered by the cylinder part. So it is not actually part of the surface area because it's not on the surface. All right, so that's the hard part that students have trouble with is the part that's covered up by the cylinder part, the half cylinder, it doesn't count as part of the surface area. So just finding lateral area is going to get you the wrong answer. So we really, for this problem, we want just the area of the front and the back. We already got the two bases are essentially the top and the bottom.
4 by 2.
And then you want the front and the back. So you have to think on your feet. You can't just use formulas every time. You have to think about what you need for the problem. Okay, so look at the front. The front is 6 by the height. So it's 6 by 4. So 24 each, right? 24 on the back, 24 in the front. So that's 48. Okay, put these two together, and you get 84. Okay, so the area that's contributed is 84. Not 84 pi, just 84. Okay, so I'll hold that up. When you go back to the video, you can see it. All right, that's straightforward. The trick here was not including the right and the left as I marked it.
I'm a bit confused. So how did you get 36 for 2b?
Well, what's this rectangle? What are the two dimensions of the base rectangle?
Okay, you did 36, and that's 18 then times 2.
And then and then the top, right?
Okay, thank you.
You got it. Any other questions before I take this board down, the orange one?
No.
Okay. I'll put it on the side if you need to see it again. I'll save that one. Okay. So what do we have? We have the cylinder, and you have the rectangular prism, and you would add those together. And we're not going to actually do the calculation, but you could use 3.14 multiply times 16.5 and then add the 84, and you will have your total surface area. Are there any questions about this problem before we move on? I'm going to admit to
Just what was the lateral area again?
Well, we didn't find the lateral area. We found the front, the back, the top, and the bottom. We did not find the left and the right because they're covered by the half cylinders. But the part that we did find is in orange here, 84. Okay.
So why didn't we find the half cylinders?
We did in green. All the green and two halves make a what? Make a hole? So
Yeah.
I just found the surface area of the whole cylinder. That's all in green. Look in green. That's all the cylinder is in green. And then we have the orange.
Also, can you mute your thing?
Who? Who do you want to mute it?
Russell, I don't know, he's doing something.
Yeah.
Oh, never mind, he muted.
Okay, good.
Go on, pin Mr. Rosenthal's video.
No,
Yeah,
he
can
was
still
kind of
hear.
loud, so I was just trying to
Give us
ask
the
him.
audio.
Wasn't muted.
All right, so no questions?
Sorry, I came a little bit late. So where did you get the 48 from?
Oh, that's fine. 48. Okay. So there's if you look at the rectangular prism only, try to get the other stuff out of your head. What parts are not covered? The top face, the bottom face, the front, and the back. Okay? So
Yeah.
if you add up all those areas separately and you add them up, the four of them, add up to 48. Okay?
Oh.
Yeah, it's the 18 and the 18. Wait a minute. No. Those are the two bases.
18 plus 18 is
No.
36.
Sorry. No. If the front and the back add up to 48. The front is 6 by 4, 24. The back is 6 by 4, 24. So the front and the back add up to 48. Okay? The bottom and the top add up to 36. Okay? And then when you add front, back, top, and bottom, that's where you get the 84.
Okay, but why didn't you include the area of the cylinder?
I did in green. So my final answer, you're right. So no, we did not do the final calculation. The final calculation would be these two added together.
Oh, okay.
So I am including it in green, and then you have the rectangular part there. Does that make sense?
Yeah.
Okay. Any other questions? All right. We're going to get into it. I got to admit, let's see, somebody's waiting with just a number and no name. Okay. Here we go. Let's go down to the next one. I'm going to erase this board in a second. We're going to do pyramids. So let me erase what I have here, and then we'll talk about, what changes from prisms to pyramids. We already mentioned it several times yesterday, and I think even the day before we mentioned what the difference is. So with a rectangular prism, okay, if you imagine this base down here, and we stretch it up, and we stop right there, then it's a rectangular prism because the bottom is a rectangle. We name it for whatever the base is. So it's a rectangle. So, but because you stopped and you have two identical bases, that's what makes it a prism. Now, what happens with a pyramid is that if you notice, this vertex goes straight up, perpendicular here to get to its own. This other, you can call it an image, pre-image if you wanted to. So does this one, comes up to here. This one comes up to here. and this one comes up to here. So you see they all go up perpendicular, right? Or it could be tilted, it could be oblique, all right? But it still has a certain altitude to get from plane to the upper plane. So think of two parallel planes. Even if it's oblique, you can slide this plane over. The planes that they're on are still parallel planes, okay? So there's still a distance between these, a perpendicular distance, okay? But with the pyramid, watch what happens. These points stay there, okay? But instead of going straight up, these points are gonna converge and you're gonna lose a base. And there's all kinds of implications when you lose this base, okay? So they're gonna all come up there. Okay? And so if you
That
want
back right one wouldn't be a dotted line. You would be able to see it.
the right one over here,
Yeah.
no, it's dotted.
Well, if it's inside the rectangular prism, then yeah, it's dotted. But you would be able to see it if it's just a pyramid.
As a matter of fact, what you wouldn't be able to see is up there. Okay, because that's all happening inside. Okay.
Oh, okay.
So anyway, I mean, we don't have to argue about the details there. You can make them all dotted if you want.
Seriously? You're doing this to me? Okay, fine.
Okay, so if you want to think of it as these points no longer exist, they all came down into like a singularity. And so obviously you're going to lose volume, but we're not talking about volume yet. All right, but when we do, that's going to be explaining why the volume changes is, you know, but what about the surface area? What about the makeup of the object? Instead of the lateral faces being rectangles now, you can clearly see they've become triangles because just look at the front face and compare it to the front face of the pyramid. When you have 4 vertices and 2 of them come and share into one point, now you still have the 2 on the bottom, but the 2 on the top have become 1. That's why it becomes triangles. So pyramids, you can always tell from looking at the net. So this is to help you again with the net to not mix up the nets. Is the one that has the lateral faces as triangles, you know automatically it's a pyramid, okay? And all prisms, the lateral faces are rectangles, and that's it. It's just those 2 things, okay? However, the surface area formulas are going to be affected because you don't have 2 bases to find anymore, right? So you can imagine what's the new formula for finding the surface area going to be. It's only 1 base area, capital B for base area. So you're only going to be responsible for pyramids for finding 1 base area, and then however many triangles there's going to be. Okay, well, there's going to be n amount of triangles. If it's n-sided base, if it's an octagon is the base, there will be 8 triangles going around it, right? So you would find the area of 1 triangle and multiply it times n. All right, and what's the area of a triangle?
1/2 base slant height.
Yeah, so 1 triangle is 1/2 base times little h is for one of the slanted triangles, right? If it's slanting in, you need this h, right? Okay, and it will be slanting in towards that point. It would look, this might be a little complicated to see because of all the stuff that's going on here. Get rid of that base there. Some of this other stuff. Oh no, we want that. Okay, so the height would go, it would be leaning, and I have some good pictures to show you later. And then you would have area of one of these triangles, and then you'd have to multiply times n amount of triangles. And that would be your lateral area, which we're going to need to add to our base area. Okay, so that's kind of, we're going to build the formula for that. All right, so
Wouldn't the formula be 1/2 BLN? Because L is the slant height.
right, but I haven't mentioned slant height yet. You guys mentioned slant height. You're getting a little bit ahead. Does it even say it up here yet?
Oh, Mr. Rosenthal,
Yes.
there are people who probably need to join in.
Oh, I have 2. Good morning. I'm going to get rid of that feature next time tomorrow because I created a waiting room. And I didn't realize that after the 8:30 time that it would still hold people in there. So I'll get rid of that for tomorrow. Oh, by the way, people just joining, the login information, I made this a recurring meeting. So that means for the week. So for the rest of this week, tomorrow and Friday, it's the same, going to be the same login information as today. It won't be a new one tomorrow and a new one the next day. And then for next week, I'll do it again for the whole week. Okay, so anyway.
Wait, is it base times height times number of sides times 1/2?
This would be the area of one of the triangles of the pyramid times however many triangles there are. And there's going to be n amount of them. N being how many
N is in the
sides,
n-gon.
N being how many sides the base has. Right, whatever n-gon is the base, right? Okay, so then that's how many triangles are going to go around the pyramid, okay? So we can tweak the formula now. I have it for another page to do it, but let's just wait till we get to the other page, okay? So let's move down. A regular pyramid is a pyramid whose base is a regular polygon and whose lateral, that's important because we're going to be mostly dealing with regular prisms and regular pyramids. Okay, we're going to assume, unless we say otherwise, assume that the base is a regular polygon, okay? And then here they mention the slant height. In some of the pictures I show you, I got them online, so they don't use L, but slant height, when I do it, we want to use L, and I use cursive L. So whenever you see cursive L, I'm talking about the slant height. Okay, and you see here that's a cursive L, it's not a slash. Okay, so if I can try to draw you slant height, well, actually I don't need to do that because I have some pictures where I can just show you on the diagram. That will save time. Okay, so here we go. Let's take a look. All right, that just says what I already said. You can assume that a pyramid is regular unless stated otherwise. Okay. Lateral area. Here's a good look at it. And we can build our formula from this page. Okay, so that's the net. What type, what is that? It's the net of a, name it by its base. It looks like it's a square because all the sides are S. And then the lateral faces are triangles, which makes it a what?
Square pyramid.
Pyramid. Lateral faces being triangles makes it a pyramid. Lateral faces being rectangles makes it a prism. Okay? All right, so that's a pyramid. What type of pyramid? Go to the base. The base is a square
pyramid.
That's it, square pyramid. Okay? So that's the net of it. All right, so now let's look at this formula. All the sides are the same. If this was an n-gon, all the sides would be the same. So let's start with all of these. Even if it's not a square, all the sides will be the same. Okay? The area of one of the triangles is half this base, which they're calling it a side, S, times this. Why do they call height slant height? Because once you put the net back, they're not going to be straight up and down. When you connect all these triangles, they're going to be slanted. Okay? And that's going to be important. They're slanted. So they're not the height of the pyramid. That's what you really have to focus on. This height is not big H, the height of the whole pyramid. Okay? It's the slant height. And it is slanted in. All right? And we'll show you some things about that. But let's take a look. Area of one triangle is right there. That's one triangle. Times n amount of triangles. So we're building the formula for lateral area. But we've done this before when we built 1/2 AP. I believe it was when we built 1/2. Yeah, it is. You take the S and the N together. If you have side plus side plus side plus side, that's the what?
Perimeter.
That's the perimeter. Okay, so even if it's an octagon, then it's times n amount of sides. You're still going to go around the object. Okay, so it's S times N. I'm going to replace that with perimeter.
Times P.
Yeah. So 1/2 PL is your
So
lateral.
it's just 1/2 AP, but stretched up a dimension.
Yeah, isn't it? Well, you still have perimeter, right? No, it's not even stretched up a dimension because we're still in area. Area is always 2 dimensions.
1/2 AP plus 1/2 PL equals the surface area.
Yeah, let's not go ahead though, okay? So, yes, surface area is going to include your lateral area right here, but also the one base that you have. So it's the base area plus 1/2 PL, the lateral area. Okay, and that's a formula you're gonna need to have. You're gonna need to know that one. Any questions about that? Take that in. So we derived 1/2 PL is gonna be the lateral area of a pyramid. 1/2 PL. Now, if you want to rationalize it, just stare at it for a second. You ask yourself, why is there a 1/2? Well, because in a pyramid, all of the lateral faces are made of triangles, and the formula for a triangle is 1/2 base times height. For a prism, there's no slant height, because in a prism, all the sides go straight up. Okay, remember what we showed you? They go straight up. So there is no slant height. That height is the height of the prism. That's why the other formula was, the lateral area was that, if you remember. Look at the difference. It has to do with the faces here being triangles and being tilted in, right? In a prism, they're going straight up. So the height is the height of the whole prism. The perimeter part is still the same. It's you get the n, you get a side n amount of times is the perimeter. So that part's the same between the two. And the part that's different has to do with triangles versus rectangles. Okay? So that kind of links the two formulas so that you're not just randomly memorizing formulas, but you get the connectivity between them. Okay?
So the base area would be just S squared, correct?
Yeah, but okay, but what if it's an octagon? Chapter
then you-
10, chapter 10, right?
Right.
Chapter
Which,
10.
so what is LA is equal to PH?
Lateral area is everything except the base. So if you're trying to find all of the area of all the triangles, you could find the area of one of them and then multiply times n amount of triangles. Okay, but we're going with a master formula here that works for all polygons. So lateral area is equal to 1/2 PL. Look here what L is. L is the height of a triangle. But when this is put back together as a pyramid, it will not be going straight up and down. It will be slanted in. I'll show you. So when you have the pyramid, say that's a square, and you have a point here, and all of these come to a point. If you take a look at this triangle, this slant height is not going straight up and down like this would be. Okay. This prism that this fits inside of, this is straight up and down. This right angle is a right angle with respect to the triangle. The triangle, I can pick this up off the table and lift it up, and that dimension is still perpendicular to its own base. So there's the difference between the information that goes with the triangle versus the information that's for the entire polyhedron. It can get confusing very quickly. It can get out of hand. Okay, so you have that slant height is what we call that. That's that L there. So the area of one triangle is right there. All right, so we did side times n of them, n amount of triangles is actually perimeter, and that explains that. Okay? All right, we don't want to beat that one to death, so let's move forward. I think it already is. Take a look at this one to show you some possibilities. Just think about it as I erase this. The same formula applies. Look at all of these. They're all triangles, except there are 6 of them because the base is a hexagon. This is a hexagonal pyramid. Same formula will apply. This one right there is going to still apply to it. Okay? And here you can get a look. These triangles are not straight up and down. Okay? They are not perpendicular to the plane that contains the base. All right? They're slanted. That's why you need a slant height. Okay, and there are n amount of them for the n-gon on the base. Here's another view. Some things that I want to point out here. Okay, if you draw a height, which is the length of the altitude, you draw it straight down from the vertex. And if you look here, you'll see a little right angle box. I know it's kind of small and there's a little bit of glare, but there is a little right angle indicator here. Okay? All right. So what you can do with that is if you take that and draw that out perpendicular to a side, and then from there, you connect that to your vertex. So let's say that again. From your vertex, down, over, and then back to the vertex, you're making another triangle within the pyramid. And when you do that, we're coming off of a chapter where we just learned comprehensively, very extensively, how to find different lengths that we need, how to solve the triangle. So we're able to capture whatever these are, even that angle we can get, right? We can solve this triangle so that we can find important pieces of information that we need to get volume and surface area of the pyramid. So let's say I have, one of these pieces of information, but I need the height, or I need the slant height, it should be L, but they're calling it A here, but it's slanted in. If I need the slant height so that I can use this formula here, then you can get that if I give you some of this other information, okay? Or how many of this length is this? You can answer.
2.
Yeah, it's 2 of these will give me what one of the side lengths are. Why would we need one of the side lengths? To get that, right? And even to get the volume, we're gonna need to know how long the side is. But if I know what B is here, double that, and that's gonna get, so this triangle that we draw in here is crucial. You need to understand the pyramid in terms of that triangle that you can draw. And when you guys are gonna work out the problems, you should practice drawing that. And if you can draw that little triangle, that's gonna be your platform to work with. You're gonna work on that triangle a lot, okay? Oh, somebody's trying to get in here. Okay. Any questions about that? No? No? Yes? Maybe? No? No? Okay.
No.
Okay. Moving along. So there's the area we talked about, 1/2 PL. You take that lateral area and you add it to the base, and you got the surface area of the pyramid. Ah, we got you a problem to work on. All right, everybody, go ahead and let me shrink this down a little bit. I want you to find the lateral area first, then I want you to find the surface, the full surface area. Let's go to 160. That's good enough. You can imagine that there's a point up there. Okay. This 9, notice, is the slant height. It is not the height of the pyramid. The height of the pyramid would be from the center of the polygon straight up to the vertex. Okay, so go ahead, take, 2 minutes, and if you need more time, I'll give it to you. Try to find lateral area and surface area. Go.
Give us 3.
3 minutes? Then I will. This one should be fun.
Mr. Rosenthal.
Mm-hmm.
So notice on the base there's like a 6-inch and then there's like a triangle and an apothem or something, right?
Yeah, that's the apothem.
Yes, but then like does the apothem solving have to do with any of this problem?
That's for you to figure out.
Oh wait,
I'm going to talk about it in about.
It is. Never mind. That's for finding the surface area.
Mm-hmm.
Oh my god. Okay.
There you go. So you're wrapping your head around it. It could be tedious, but
I mean, I see why, because like it's I mean, actually this is gonna be so hard because if you split that triangle in half, then it ends up in the base as 3.
Mm-hmm, that's right.
It shouldn't be that hard. Plus it's a hexagon as well.
This Joseph.
So
Joseph, is that you talking?
Yes, that's me.
Yeah. What Joseph is saying is that this is 3 because this whole length is 6. Okay, that's what type of triangle is that, by the way? If
That's a 30, 60, 90.
What's this bigger triangle though?
It's just the equilateral triangle.
It's equilateral, right? So then when you split that, you get a 30, 60, 90. Oh, while you're doing that, you guys already have the formula in your notes. I better start drawing it so I can start working on it. Yeah, I've been avoiding green for a while. Let's get back to green.
I used my master formula for the area of the hexagon.
Which master formula?
The one where you can solve the area of the regular polygon just by using x.
Oh.
I'm using it too.
That's really helpful.
The one that we did in 5th period?
Yeah.
You want to remind us of that formula?
It's n x squared over tangent theta.
And what's theta again?
Nx squared over tangent.
Oh, that's right.
Theta is the half angle.
Theta is the half angle? And some people are probably thinking, what half angle are you talking about? That's okay, we'll get to it. This is a shortcut that we discovered in, or David discovered in period 5. If you have x, x being this half length right here, the 3. If you have that x, if you plug that in to this, you get the area of the polygon. You're going to need that half angle there, which is 30 degrees. Okay. I cannot draw a straight line with this board crouching down. I am having trouble. Here we go. There we go. There we go. Okay, good. Oh, we're past the 3-minute mark. Do you guys need more time?
No.
Well, if you need more time, say yes. Otherwise, you don't need to say anything.
I got the lateral area, but I'm trying to find the area of the
So I'll
6 inches
extend a minute.
the length of one of the sides, or is it the length of like the apothem of the base?
That's 6 inches right there.
Is it also possible to find the lateral area just by finding the area of one of those triangles and multiplying that by 6?
One of the bigger triangles?
Yeah, like 6.
But that is what you're doing when you're using the formula, and you are more than welcome to do that because that is an intuitive way to do it, which is great. Do it that way.
Is N6.
Thanks.
But you're finding the area of one of these triangles is 27, and then you're multiplying 27 times 6. That's fine. What I'm doing is I'm doing 1/2 PL for the lateral area. 1/2. The perimeter of the base is 6 times 6 is 36. Okay? The slant height is 9. So I'm just plugging it in there, and I'm doing 18 times 9. You'll get the same answer, right? Or I like 9 to 81 times 2 is 162. Okay, so I got 162 for my lateral area.
Yeah, as did I.
Did I?
So did I.
All right, so
Correct.
there we have lateral area. I used 1/2 PL. The perimeter, if you didn't catch that, 6, 6, 6, 6, 6, and 6. It's 6 times 6 sides. Perimeter of the base, that's what this is. Lateral, or excuse me, that's not slant height. If I said lateral area, if I said something like that before, I don't know. But slant height, L, cursive L, lowercase, that's this 9 here. So you had all that information given. This was an easier case. I'm going to give you problems where you don't have that given. You have to find that. Okay. All right. So now how do I find the area of the hexagon? So you could plug your stuff
1/2
in
AP.
for David.
Nx squared over tangent.
All right. Let other people think about it. But the area of the hexagon is 1/2 apothem times perimeter. Well, we already have the perimeter, and you already have your constant 1/2. Perimeter was 36. So really we need the apothem. So how do I find out what this apothem is? Well, if you know that this distance here is 3, and you have your little triangle here, and this is 30 degrees, and this here is the 60 degrees, the 3 is across from the 30. So across from the 60-degree angle is, if you know your ratios, is 3 root 3. Okay. 3 root
Nice.
3. All right. So your apothem is 3 root 3. I hope you guys have your calculators on hand.
Could
Okay.
you also find the apothem using like trig function?
Yes, you can. So if you're trying to find apothem, it's opposite over adjacent. So tangent of 30 degrees is equal to the 3 over the apothem. And those will switch out. Apothem is equal to 3 over tangent 30 degrees, which is kind of what this is going to look like. Okay. All right, so now what? Now you're going to finish this here. So let's get that out. So you have 18 times 3, 54 times rad 3. Get out our calculators. And you'll round to the nearest tenth.
93.5.
So 54 times rad 3, which is about 1.7. And you get about?
93.5.
That's a nice sum. Okay, so this is your base area. We got that with 1/2 AP. That's a chapter 10 concept. Okay.
Is the base always made up of 30, 60, 90, like not 30, 60, 90, but is it always made up of isosceles triangles when
Yes.
like going around the vertex?
Yes, because of what we said that we're going to stick with regular polygons as the base.
Yeah, I just read that. It said you can always assume that it's regular. Assume like
Yeah.
it says on.
Yep. And then for the total surface area, you're going to add these two together. So you add your 162. So surface area is going to be about 255.5.
255.53 inches squared.
Okay, so this would be what you might see on a test, okay? So ask your questions now or forever hold your peace.
How did you get 36 for the slant height, for the lateral area?
I didn't. Oh, over here?
Yeah.
Look up above it. Perimeter. Perimeter of the hexagon.
Oh.
Oh, I love that. Oh, I love that. Oh.
So when you're finding the lateral area, you need the perimeter of the base?
That's what that P is. Perimeter of the base.
Okay.
I would note that. So you know in your notes
Sorry.
what that is. Any questions?
My 4 health.
Bueller? Anyone else?
So can we always use that that formula for 30, 60, 90 triangles for any of these polygons?
Well, it makes it faster. But,
I mean, because I like the method a lot. I'm just wondering, are there any like scenarios, assuming it's a regular pyramid, where we can use it?
if it's not a hexagon, right? If it's not a hexagon, what is the half angle when it's an octagon? Do you guys remember it? Say first.
22.
It's 22.5.
It is, exactly. So it just depends on what it is. What is it for a pentagon?
36.
It is 36, yeah. So if you already have those memorized, then you know what that is, okay? And then you could do tangent of that angle, okay?
Oh, right.
Then you would
I
be,
forgot about that.
yeah, and you would be using this, okay? So it would be, in this case, it would be 3 if that was the side length was 6, but it was a different base, like a pentagon. Then this would be tangent of 36, okay? All right?
Wait, can you show what to plug in for nx squared over tangent of theta?
You're going to plug in the 3.
So x would be the aperture, the half.
It would be half. It's this half side.
Okay.
3. 3 squared is 9. 9 times n, right? There's six sides, so you get 54 over tangent of the half angle, which is 30. And what did that give us, David?
What?
What does that give us if we do that?
Oh, 93.5.
I mean, we can do that. We can plug that in. So you have 54 divided by tangent of 30.
Yeah.
Yeah, 93.5. Okay, I don't.
I can see it.
All right, so that formula, if you want, works when you have the half-set. We also made formulas for when you have the apothem and when you have the radius.
N.
Now, David, do you want to give those out since you discovered them? Sure. Okay, so
N r squared cosine theta sine theta.
that's if you have the radius. That will quickly give you the area of the whole base, real quickly.
And n a squared tangent theta.
So is n just the amount of sides?
Yeah.
Yes.
Yep.
Okay.
So I know half of you out there are drooling over this one because it saves you a lot of time. We derived these in class with the unit circle. Somebody's got their video on up here.
Yes.
Let's go.
Oh, I don't know if I might have closed out his chat instead of his video. I don't know.
No, his video's out now.
Okay, good. Any other questions about this problem? You're going to get more, so maybe we'll move on, and you can ask on the next one.
I have a comment.
Comment, Cal.
Well, it's not really about this, but the infinity gauntlet for math geeks is a circle plus slit.
It's a circle plus what?
Slit.
I'm not understanding that word you're saying.
Circle plus TLET equals the infinity gauntlet.
TLET is a word?
No, it isn't.
No.
But what I'm saying is a circle is an infinity gauntlet.
I'm with you now.
Oh,
Okay. Well, thank you for
My
that.
jokes are bad.
I think I'm sorry because when you make somebody explain a joke, it loses its.
It's clever. It just doesn't make enough sense to be funny.
That's okay. That's okay. All right. So here's another problem for you guys to work on. This one's probably a calculator problem. So go ahead. The lateral area of the Great Pyramid at Giza. You are not finding the surface area because that part is on the ground. So you're only finding the lateral area only. Those are your dimensions. The height of the whole pyramid is given this time. Guess what they don't give you this time? No slant
height.
The side length that goes all the way across one side is 756 feet. And these are probably approximate measurements from the real pyramid. So go ahead and take 3 minutes for this one. Go.
Пап, мама до сих пор спит.
Нет, я как уже отвезти. Так, вставайте, она сейчас приедет через 3 минуты. Она будет дверь, поздравить ее. Еще нет, но скоро ухожу, да. Мама сейчас приедет. Хотите ее поздравить с днем рождения?
Are we gonna do anything?
You guys want to mute your mic.
Подарочки.
But
Mute yourself, please.
I need to finish my list.
Что он делает?
David, can you let other people figure it out? Sorry.
Thank you. Yep, that's a good point. So again, while you guys are working,
Thank you, Ian.
if you're stuck,
You're welcome.
remember that you might want to draw out this triangle that we had mentioned. So you have this right triangle that you can make. Okay, so we have this 481. What's this dimension? You're going to need to find out what this is. This is not too bad of a problem.
It's pretty bad.
It's pretty bad, even with your calculator?
I'm struggling to find the slant height.
Okay. Did you find this little distance?
That's just half of 756, correct?
Yep. And then you know this height here?
Like a triangle. Okay.
It's a right triangle, right? Can't you
Right.
find the hypotenuse?
Yeah.
There you go. Almost coming up to that 3-minute mark, but that's okay. Who do we got here? Stop video. Oh, that's David's video. Okay, we're past the 3-minute mark. Does anybody need more time?
Can I get a little more time?
Of course. We got all day. We got all day, guys. No, I know you have some other stuff going on later.
We're not gonna have any This isn't for you, Mr. Arsenal. This is for the other students in 8th grade. We're not gonna have any like history lectures today, are we?
No, it's only Tuesdays and Thursdays.
Yeah, that's what I thought. Thanks, Shay.
Of course.
He said Monday too, didn't he?
On the schedule. He posted a schedule on School G.
It's only Mondays. It's not Mondays. It's just Tuesdays and Thursdays.
Yeah.
From
All right,
30 to
guys, here we go. Let's talk about this. 378, I think. Is that right? 378 is this half distance here? Yes? Okay. And then you have this distance here. And so we'll get the hypotenuse, which will be the slant height. Okay, so I'm going to do 481 squared plus 378 squared is going to give us our slant height squared. And I'll take the square root and to get the slant height. And I'm going to go to the calculator. Okay, so I have, here we go. Get that going here.
Oh my god.
611.8.
481 squared plus.
I concur.
I got 374,245, and then I'm going to square root that.
But you get 611. How can the hypotenuse be smaller than the sides?
Okay, hold on. Let's talk about that. 611.8 about. Notice I'm going to leave that value in my calculator. This is rounded, but I'm going to leave that value to try to get it more accurate for my final answer. Okay, so this is what I got for my slant height. This slant height may be smaller than this, but this was not one of the legs of the right triangle, was it?
No.
Daniel, this was the leg. The 378 was the leg, not the 756. Daniel, you see that?
We have to find the slant height of the actual slants.
This slant height here is what L is 611.8. Daniel,
Okay.
Did you get that, Daniel? Where did Daniel go? Okay, so anyway, we have the slant height. You are now ready to go to formula. 1/2, the lateral area is 1/2 EL. Well, the perimeter is 756 times 4.
Times 4, yeah.
4 of those. 1, 2, 3, 4.
Times 481.
3,020.
3,024. So I have 1/2 3,024 times my 611.8, which I still have in my calculator more accurate than that. And then I'm just going to go ahead and do that. So I have my 611.8 now. I'm going to multiply by that and cut it in half. Oops. Times 3,024.
924,974.
0.5. Okay. So
Well,
I
put in
have
the more like accurate one.
I have that number. 924.974 9, but then the 7 rounds it up, so we got 925. Okay.
I manually inputted my answer like as far as I could see it. For the square root of like to get the lateral or to get the slant height. And I only got up to 0.5733.
Okay, give me 1 second. It's that's a comma, not a decimal. 924, 974.
Wait, Ben, what happened?
I got a smaller amount of decimal points because of the way I manually put in the number.
Okay, so say it again, Ben. I'm sorry.
I only got 4 decimal places because I manually inputted the 611 number instead of using it. It was already in my calculator.
You put 611.8 in there?
No, I put 611.75560.
Yeah, that's what I put in
Instead
there.
of like hitting answer, I just manually inputted the number.
Okay, that's fine. Did you get close to this?
Yeah, I got up to 7 or 0.5733.
Which is going to give you 0.6. And I got the 0.5733 as well. Okay? All right. Yeah, you guys, if you have noises in the background, I think I just heard a toilet.
Yeah, I hope that's not.
Yeah, let's mute yourself unless you're making a comment or asking a question. So the lateral area of this pyramid is, about 925,000 square feet, right? Pretty big. Any questions about this problem? These are meaty problems. You have to really get in there and work with the numbers and check your calculations. Okay, any questions? All right, let's move on. Getting close here to the end.
Wait, so for clarification, the lateral area was something around 462,520.
This lateral area, 924,000. That's what I got from 1/2 perimeter times slant height. Okay? Okay.
Yeah, yeah.
All right, so what about polygon, what are regular polygons with infinite sides? Hello?
Circle.
A circle, that's right.
A circle.
So how are we going to make this? What happens with a pyramid if the base is a circle? It's not called a pyramid anymore, but it's called a cone. But it's the same thing. It's going to act the same way. It's going to have all the same pieces. It's going to even have the same formula. Before I go any further, let's all just quickly derive what that formula is going to be. Don't shout it out. Just watch along. You can think it out. Try to write it out on your paper. You're welcome to write it in the chat. I can see it there. So now the base is a circle, and all these points meet up they converge on that point there, okay? You can still draw the same triangle that you did before. Call that big H, okay? You still have a slant height, L, but you don't have the sides anymore. There's an infinite amount of them. So this formula still works though, because that's for with any base, any regular base. So perimeter is now circumference. So 1/2 PL, let's work on that. Circumference times the slant height. And then circumference is
pi r, 2 pi r or pi d.
And then look at what happens with the 1/2 and the 2.
Cancels.
Yeah, leaving you pi RL. So lateral area, pi RL. And we can go further. What's the total surface area of the cone? It's going to be the lateral area plus the base, right? The base area, right? So if the lateral area is pi RL and the area of a circle is pi r squared, what can you factor out if you want to get a minimized formula?
Pi r.
Yeah. And you just get what?
It would just be LR?
Yeah. So if you look, what do you need to get the surface area quickly? You want to get that radius and you want the slant height. But if I give you big H, you can use the Pythagorean theorem to get slant height like we did in that other problem. Okay? So that's what you want. And then once you have that, it's R times pi times the sum of R and L. You just kind of add these together, you get this, and then times R times pi. And that's the
It's 9:30.
That's the entire surface area. I know, we can go over the time. That's okay. We're not going to go way over the time because I know your next meeting might be, 11:30. Who knows? Well, I'm not going to go to 11:30, or excuse me, might be 10 o'clock. We're not going to go to 10 o'clock. So I don't think does anybody have anything going on this morning other than this?
I mean, I had to eat
I
breakfast.
have American Images.
What time is American Images?
I have fourth period.
11.
Yeah, we're going to go like another few minutes here. I just
American Images is at 12. He changed it.
Yeah, he
I
did.
wanted to try a phone problem. So here we go. That's all the stuff I just did already. So we're past all that. Okay. There's the net, by the way, for a cone. There's the net. You get this weird triangular wedge that comes out. And then that circumference wraps around this circle here. Okay.
Mr. Rosenthal, this is a bit of a side note, but for the problem I got wrong a while back, I actually just got it right. He just made a careless error, so it's all good.
That's good news. Understanding how to do it is good news. Okay, try this problem out. This was our derivation. You go back to the video later if you need it. This is going to give you the full surface area. The lateral area, though, if you just know this formula, you might have trouble with the lateral area. So this part is the lateral area right here, pi RL.
Should we get the answer in terms of pi?
Yeah, let's do that to save a little bit of time. Well, that one's going to be pretty quick. Sorry. Is that what you got? And the base area. See, I'm not even using this. I'm doing it more intuitively. Get that lateral area out there. So pi RL is really, I think, more important to memorize than this. And then the base area, I could just add to it if I want. Pi r squared, right? So 225 pi. Now put this together with this. 600 pi. All done. I'll take questions at this point.
So with the homework, are we just turning it in when we get to school?
Yes, but that can change because the governor put out that it's possible that this is going to last all the way to summer for the rest of the semester.
Oh, yeah.
But
happens if that
hold on, everybody. Hold on. Just hang on there. Hold on, dear Riches. Okay, listen. Right now, we're going to go as if we're coming back in 2 weeks. If it does come to pass that we're not coming back for more than 2 weeks total, starting from Monday, then I will have information for you on how we're going to do that. I'll probably
off the record.
Sorry, I was distracted. Why pi RL?
Okay, we can go back to that. So the lateral area is 1/2 PL, right, for all the regular polygons.
Okay.
So that's going to work for the circle for the cone because.
Oh, I get it. Because the perimeter is the circumference, and then 1/2 of that is pi r.
Yes, and I had that derivation. I got rid of it. You can go back to the video if you'd like. I think.
Off the record. Do you believe that?
Okay, let's go back to that other question.
So off the record, do you believe that this is going to be more than 2 weeks?
I do believe it will. Okay, so I'm already thinking of ways I'm gonna.
No, it's because I've been doing something.
I don't want to give you misinformation or give you. I want to think it out a little bit more and have a plan before I get that out.
Are we gonna have tests?
Okay.
Like I said, I don't want to say anything now. I want to have a full plan before I give you information.
And I have a question. So if it does go into the
Let's
summer,
hold your question for a second. Let's actually finish this, and then at the end, I can answer some more questions.
okay.
I think this is going to be the last. Yep, this is the last problem. So let's do this problem. I'll give you the homework, and then I'll leave it open for questions. So if people need to go, they can. Okay, so go ahead and start this problem. And we're almost done here. This time I'm giving you the height and not the slant height. So see if you can put that together. I want both the lateral area and the surface area.
Alrighty then.
Okie doke.
I got an answer.
Nice. Starting to gel.
Go Shy.
You can post it if you'd like on the chat.
Oh.
That way I have it so I'm the only one who could see it when you post it to me.
Yeah, as do I.
Yeah. So it doesn't give it away for everybody else. Bless you.
That was a big one.
Now, is that answer you're giving me just the lateral area, or is it the total surface area? Oh, I have people giving it to me in decimal form and in terms of pi. I'm going to leave mine in, I don't know what I'm going to do. I'll wait till I do it, and then I'll see what I want to do. I'm getting different answers, so you guys are not all getting the same thing. Might want to look at it. All right, to save some time, I'm going to just go over it, and you can look at it on the video. So go ahead and just sit back there and take a look. So lateral area, pi RL. Okay, radius is going to be 4. Lateral, or not okay, this is slant height, pi RL. L is slant height, so I need to find that. So this is 7.4 squared plus 7.5 squared. Take the square root, and that will give me L. So I have, so 56.25, 16, 72.25, I think that's going to be. Yep. Yes? Squared.
Yeah.
And then, okay, so I have 72.25. I'll take the square root of that. 8.5.
Yeah, 8.5 times 4 times pi.
Right, so I'm
Which
going to
gives you 34 pi.
Does it? Okay, yeah.
Yeah.
Yeah, 34 pi. Great. I love that. Okay. So that answers my first one. Second one is just the area of the circle. That's it. So it's 16 pi. And I could put them together and get 50 pi is the surface area. I'm going to leave it like that. 50 pi square centimeters. And I'll take any questions about it.
Mr. Rosenthal.
Yes.
Can you explain the lateral area again? Because like I missed stuff.
Lateral area for the cone is pi RL.
Wait, how did you get 8.5 on 4?
Okay. Let's bring it over here. This is a right triangle.
Mm-hmm. Or using Pythagorean theorem.
Yeah, exactly. 4 and 7.5, those are the legs, and I used the Pythagorean theorem, and I got 8.5.
Oh, okay. Makes more sense.
Any other questions?
It's a question regarding the coronavirus, like...
Hold on. Oh, wait 1 second. We'll get to that. Any other questions about this? No? Okay. You could ask questions on Schoology, because in the afternoon I check Schoology. So if you need any comments or questions there, you can go ahead and do that. Here's your homework.
Oh, it's not that
my
much.
gosh, that is so much homework.
I know,
My
right?
goodness. I don't know how you're going to have time to do all that.
I hate you.
Mr. Rosenthal, you're literally killing us.
That was rough.
Yeah,
You're
not
really
literally. You guys are misusing.
Daniel, that's not nice.
Mr. Rosenthal, you're working us to an early grave.
You know, I think Mr. Rosenthal is the nicest teacher this break so far.
Oh, no. Let's not do names and things like that. No name calling.
Actually,
A certain teacher that teaches geometry is the nicest teacher we have.
Okay, that's okay. All right, so now I'll take any questions. You guys are welcome to go now. If you're done and you don't have any questions, thank you, and I'll see you tomorrow.
Thank you, Mr. Rosenthal.
Same
Thank you.
Bye. Thank you.
Thank
Bye.
you.
Welcome.
Thank you.
Nobody has any questions about anything else?
Rosenthal, I have a question.
Okay,
So I'm just
be a little bit
curious.
louder. Talk into your mic.
If this goes into the summer, do you think that we'll be ending up having an extended school year, or
No.
will we just like miss? Like, I guess I don't know if we're having a graduation necessarily, but like,
are we having finals?
Is Sun even here?
Well, that I cannot answer. If we're having finals or not, that's going to be so. All your teachers are constantly, even right now. I'm getting
Don't reinforce this.
I'm getting texts and emails from Ms. Huff, Mr. Lauchu, and all of the other staff. We're constantly collaborating. So that has not been discussed yet because we're not at that point. But we'll get that information out to you when we know. We're not going to hold on to that information and not tell you. So once we know what we're going to do with that, then we'll get that information out to everybody.
I think I definitely agree with you. How it's inevitable that it'll be longer than 2 weeks.
Well, we don't want to do this again a month later. We
Right.
want to try to flatten that curve out if you've seen that curve.
Yeah, we're trying to prevent what's happening in Italy, where we're having shortages of supplies.
And it has to do with population density. When everybody's close together, conductivity goes up, right?
Right. So in the event that it does get worse and worse, how long do you honestly think it's going to last for?
I have no idea. I'm not an epidemiologist, so
okay.
Yeah, I'm not sure. I think with if everybody really puts in their share of social distancing, it really cuts down on the density issue out there, and conductivity is going to go down automatically just from more people doing it. So it's not like every single person has to do it. It's just more people have to social distance, and the more that we do that, the better that's going to be. So we just have to see.
Did Sun ever show up?
I don't know. We're not going to discuss, who is here individually. People can access this on YouTube. I'm going to post this on YouTube.
Sir, it showed up on the first live.
Is it looking optimistic from here?
Everything looks optimistic to me.
In regards to coming back to school, like after the 2 weeks, is it looking optimistic?
That I don't know, and I don't even know if that's a good idea because, 1 week and then spring break, So I would think that it would make sense to just go through spring break, and then after the 4 weeks, it might be looking like that's a possibility. But you know what? Coming back after 2 is what was said, so that has not been changed. So as of right now, we're coming back after 2 weeks. So it's tentative. We have to just wait to see what word gets out.
My parents got an email saying it's not going to be back until the end of the semester.
That I don't know. But what I do know is we have to finish up this discussion because I'm starting my pre-algebra soon. So I want to start prepping for that.
See you, Mr. Rosenthal. Thank you.
Tomorrow, same time, same login information.
Thank you. Bye.
How do we turn in the homework?
You don't yet. Right now, you hold on to it. But it might be where I'm going to have everybody submit it on Schoology.
Okay.
Yeah, like your picture.
Okay, but don't do that yet. I don't have a plan for that yet. So if the 2 weeks comes and we do go back, or even the 4 weeks, I'm going to just have you show it when we get back. Otherwise, once I know what we're doing, if I know it's going to be more than that, then I'll have a plan for that. Okay?
But aren't we going to have spring break in 2 weeks?
Well, now, if you count the beginning of this week, it would have been 3 weeks. So if after this week, it would be 2 more weeks.
Oh, okay. I got you.
When we finish this week, there's technically supposed to be only 1 more week of this leave. All right. But, we'll see what happens. Okay. All right, everybody. I will see you tomorrow. Enjoy the rest of your day. If you have any questions, contact me on Schoology. I'll be checking that today.
Mr. Rosenthal?
Yes.
Were you drinking a Snapple?
Yeah. You want the fact?
Yes, please.
The fact today, Oregon has more ghost towns. Oregon has more ghost towns than any other U.S. state.
Okay.
Okay.
Bye.
All right. Bye, everybody.
Bye, Mr. Rosenthal.
See
Have
you
a good
later.
day.
You too.